Welcome to part 1 of lesson 1 in our interactive notes for trimester 1. If you have not yet put your name on, make sure you do so. And your number. My number is the number pi, which is a number. All right, so let's look to our table of contents. Lesson 1, Divisibility Rules. So we need to turn to pages 5 and 6. So as we look at the bottom, okay, at the very bottom it says page 5, so this is the page we're going to begin with. So you want to make sure you have a pencil and a highlighter for today. So you need your highlighter, and make sure you're using pencil, not pen. I only use pen because pencil's too light on the video. Okay, so this is our first lesson. These are our divisibility rules. So our content objective, it's 4th grade. OA is Operations and Algebraic Thinking, B4. I can find all factor pairs for a number from 1 to 100. Our language objective, I can use the divisibility rules to find the factors of any natural number. And social objective, I can work with others to create models to prove factors and multiples of numbers. So here we have some vocabulary, and I want to show you at the very back of our folder here, we have what's called a vocabulary index. An index is something at the back of informational text that helps you find what you need. So here all the vocabulary words are listed, so if you need to know what a word means, you can look back here. It'll tell you what lesson it's in, what standard it belongs to, and what page number. And when you turn, you'll see one of these, and these are our vocabulary. So our vocabulary, we have whole numbers. Whole numbers are 0 and positive numbers without fractions or decimals. So here we have a decimal, so this would not be considered the whole number. The 2 would be the whole number, and then the rest is a fraction, where 24 is a whole number. This only part of this would be counted the whole number. Product. The answer to a multiplication problem, factor times a factor equals a product. So factors multiply together to make a product. A multiple. A sequence of products using the same base number multiplied by different numbers. That needs a T. So 56 is a multiple of 7 because 7 times 8 equals 56. Divisible. When one number can be partitioned into equal groups with no remainder. This is what we do with our daily fraction. So if it's divisible, that means you have no remainder. You can divide by a number and have a remainder, but that wouldn't be considered divisible. Factors, the numbers that are multiplied together to form a product. So 25 times 5, these are our factors, equal this product of 125. So factors multiply together to make products. Factor pairs, the numbers that when multiplied make a specific product. So 1 times 12 makes 12, 2 times 6 equals 12, and 3 times 4 equals 12. So 1 and 12, 2 and 6, 3 and 4, those are all factor pairs. We have common factors, factors of different numbers that are the same. So in 6, 12, and 14, 2 is a common factor. In 6 and 12, 3 is a common factor, and 6 is a common factor. Also 1 is a common factor for all of them. And we have greatest common factor, the highest number that divides exactly into 2 or more numbers. So the greatest common factor of 10 and 18? Well, the number that appears in both is 2. It's the greatest common factor. Here, the multiplicative identity property, and that is multiplication of a number by 1 in any form results in a product equal to the original number. So basically, the identity property of multiplication says you multiply by 1, it stays the same. The commutative property of multiplication, factors can be multiplied in any order and the resulting product is the same. So here, 2 times 3 gets us 6, and 3 times 2 gets us 6. Doesn't matter the order, we still get the same product. Alright, so now we're going to look at our divisibility rules. We're going to use this every day with our daily fraction, and this is going to help us to decide and figure out what all our factors are. So with your highlighter right now, we're going to use these hundreds charts to identify multiples of different numbers. So here our rule is a number is divisible by 2 if it is even. And even numbers are ones that end in 0, 2, 4, 6, or 8. The only exception is 0. It's considered neutral. So here let's highlight all of our even numbers. So 1 is not even, it's odd. Anything that ends in a 1 is odd. 2 is even, and anything that the last digit is 2 is even. So I'm going to highlight this whole column. Okay, 3 is odd, so everything that has a ending digit with 3 is odd. 4 is even, so anything that has an ending digit of 4 is even. 5 is odd, so anything that the last digit is 5 is odd. 6 is even, so anything that has that last digit as 6 is even. 7 is odd, so that last digit, if it's 7, is odd. 8 is even, so anything with the last digit of 8 is even. 9 is odd, so anything with the last digit of 9 is odd. And 10 is even. So these we've just highlighted are all multiples of 2, and that also means that each one of these numbers can be divided by 2 with no remainder. Now we're going to look at the rule for 3. A number is divisible by 3 if you add all the digits. First, you add all the digits. Second, if the sum is a multiple of 3, so then is the number 3, 6, 9, 12, 15. So we add all the digits in the product. So an example, 654. We want to know if that's divisible by 3. Will it be divided evenly by 3? Well, if you add these 3 digits together, 6 plus 5 plus 4, 6 plus 5 is 11 plus 4 is 15. 15 is a multiple of 3, so that means yes. 3 is a factor of 654. So we're going to highlight each one of those. So we start with 3, 6, 9. Okay. And you can count over. 1, 2, 3, highlight. 1, 2, 3, highlight. 1, 2, 3, highlight. 1, 2, 3. Next one is 12. 1, 2, 3. Then we get 15. 1, 2, 3, 18. 1, 2, 3, 21. We start getting a pattern of a diagonal. 1, 2, 3, 24. 1, 2, 3, 27. 1, 2, 3, 30. 1, 2, 3, 33. 1, 2, 3, 36. 1, 2, 3, 39. 1, 2, 3, 42. 1, 2, 3, 45. 1, 2, 3, 48. 1, 2, 51, 1, 2, 3, 54, 1, 2, 3, 57, 1, 2, 3, 60, 1, 2, 3, 63, 1, 2, 3, 66, 1, 2, 3, 69, 1, 2, 3, 72, 1, 2, 3, 75, 1, 2, 3, 78, 1, 2, 3, 81, 1, 2, 3, 84, 1, 2, 3, 87, 1, 2, 3, 90, 1, 2, 3, 93, 1, 2, 3, 96, 1, 2, 3, 99. So we've got all these diagonals that show there. Okay, next one. A number is divisible by 4 if the last two digits, we just look at the last two of a number, are divisible by 4. So here we have an example of 624. Don't really care about the 600, I just look at the last two digits of 24. 24 is a multiple of 4, so that means I can divide 624 evenly by 4. So now we're going to find all the multiples of 4 here. Show all the numbers that are divisible by 4. So we count over 1, 2, 3, 4. We get 4. 1, 2, 3, 4, 8. 1, 2, 3, 4, 12. 1, 2, 3, 4, 16. 1, 2, 3, 4, 20. 1, 2, 3, 4, 24. 2, 3, 4, 28. 1, 2, 3, 4. So you may be starting to see a pattern here with what you're highlighting. So 32. 1, 2, 3, 4, 36. 1, 2, 3, 4, 40. 1, 2, 3, 4, 44. 1, 2, 3, 4, 48. 1, 2, 3, 4, 52. 1, 2, 3, 4, 56. 1, 2, 3, 4, 60. 1, 2, 3, 4, 64. 1, 2, 3, 4, 68. 1, 2, 3, 4, 72. 1, 2, 3, 4, 76. 1, 2, 3, 4, 80. 1, 2, 3, 4, 84. 1, 2, 3, 4, 88. 1, 2, 3, 4, 92. 1, 2, 3, 4, 96. 1, 2, 3, 4, 100. All right, now we look at 5. And this one's a very simple rule. It ends in a 5 or a 0. If the last digit's a 5 or it's a 0, then 5 is a multiple. And the only two columns are the 5 columns here, that it ends in a 5. 5, 15, 25, 35, 45, 55, 65, 75, 85, 95. Those all end in a 5. And 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, those all end in a 0. So all of these are multiples of 5, or 5 is a factor of each of these numbers. Now we go on to the divisibility rule for 6, that both 2 and 3 are factors. So that means the rule for 2 has to work, they're even, and the rule for 3. If you add the digits together, that sum is a multiple of 3. Okay, so let's go ahead and highlight all of them. So we go with 6. Then we count over 6. 1, 2, 3, 4, 5, 6. We get to 12. Count over 6. 1, 2, 3, 4, 5, 6. We get to 18. Count over 6. 1, 2, 3, 4, 5, 6. We get to 24. Count over 1, 2, 3, 4, 5, 6. 30. 1, 2, 3, 4, 5, 6. 36. 1, 2, 3, 4, 5, 6. 42. 1, 2, 3, 4, 5, 6. 48. 1, 2, 3, 4, 5, 6. 54. 1, 2, 3, 4, 5, 6. 60. 1, 2, 3, 4, 5, 6. 66. 1, 2, 3, 4, 5, 6. 72. 1, 2, 3, 4, 5, 6. 78. 1, 2, 3, 4, 5, 6. 84. 1, 2, 3, 4, 5, 6. 90. 1, 2, 3, 4, 5, 6. 96. And then there's only 4, so we're done. Still see some patterns going on there, kind of diagonals with a blank one in between. Now if you notice, there's not a rule for 7. There really is a divisibility rule for 7, but it takes so many steps to follow it. It's sometimes easier just to count your multiples of 7 or just divide by 7. The rule is not any faster, so if it's not going to save us any time, I don't see why we need to learn it. Okay, a number is divisible by 8 if 4 is a factor and its companion factor is even. So if 4 is a factor and then whatever that number is multiplied to is also even, it works. So here 6 times 24 is 4 times 156. Well, 156 is even. So that means that this number can also be divided by 8. So let's find 8. Count over 8. 8, 16. Count over 8 and 24. Count over 8, 32. Count over 8 and 40 more. Count over 8, 48. 56, 64, 72, 80, 88, 96. Okay, 9 has the exact same rule as 3. Whatever the number is, you add all the digits together, because remember, digits are like the alphabet. All numbers are made up of digits, just like all words are made up of the alphabet. So we have only 10 digits, 0 through 9, and every number is made up of that. So I have 1, 2, 3 digits here. 3 plus 4 plus 2 equals 9. So that means I can divide this number by 9 and have no remainder. Okay, so let's look at our 9s. 9, 18, we get a diagonal here. 27, 36, 45, 54, 63, 72, 81, 90, 99. And each of these digits, 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9. They all follow that rule. And then 10 is a pretty easy one to remember. If the last digit is a 0 or it ends in a 0, then 10 is a factor. So these are all multiples of 10, or 10 is a factor of each of these numbers. Okay, now it's time for the 3-column notes.